So today we have an interesting geometrical problem. We take a square. Now taking the top left corner as the center, we draw a quarter circle inside it. Now we draw a semicircle so that one end of its diameter is the bottom right corner of the square and the semicircle is also tangent to the quarter circle. Now we draw a complete circle so that it is tangent to the right side of the square and the circle is also tangent to the quarter circle and the semicircle. Now we mark 3 points inside the diagram. The first point is the center of the circle, the second point is the center of the semicircle, and the third point is the center of the square. Now we draw a triangle connecting these 3 points. So the question over here is to find the area of this particular triangle when the side length of the square is of 12 units. So this is Anmol, and now let us see the solution. How can we solve this problem? Now let us start with the solution. So the first thing we can notice over here is that we have the value for the side of the square, and using this we have to find the area of the blue triangle. Now what I am thinking is to generalize the solution by taking the side length of the square as a variable x. Okay. So now we have to get the area of this blue triangle in terms of an equation in which the variable present would be x. And this equation will be obtained by using the arrangement of this diagram. Okay. So the first step in our solution is to mark each and everything present in this diagram in terms of x. So already the side length of the square has been taken as x. Now as it was given, A is the center for this particular quarter circle. Therefore the distance AB and the distance AD becomes the radius, and directly its value is x. So we have got the radius for this quarter circle, and that is equals to x. Okay. So now the next goal over here is to get the radius of this semicircle in terms of x. So now there are two things given for the arrangement of the semicircle. The first thing is that it is tangent to the quarter circle, and the second thing is that one end of its diameter lies as the corner of the square. So first thing that I will do is I will take the radius of the semicircle as a variable y. Okay. This is the center of the semicircle, hence the distance from center to the point C would be equals to y. Now the distance from D to C is the side length of the square, that is having a value x. Some part of it is already equals to y. Therefore the remaining distance, that is from D to the center, let the center be point P. So now the distance from D to P would be equals to longer minus the shorter, that is x minus y. Okay. Now we know this particular fact that if there are two circles that are tangent to each other either externally or either internally, and then we mark the center of both of these circles. And now if we draw a line segment joining this center, they will also pass through this tangent point. Either the case is external or either the case is internal. In both the cases, the center of both of the circles and the tangent point are always collinear. So the same thing we will utilize over here. As we can see, the semicircle is tangent to the quarter circle. So ultimately they are circular figures. Therefore the center of the quarter circle, the tangent point, and the center of the semicircle would be in a straight line. Now if we look carefully, we can see the distance from the point A to this tangent point is ultimately the radius of this quarter circle, hence it would have a value x. Now similarly the distance from the point P to this tangent point is the radius of this semicircle, hence it would have a value y. Now as these 3 points are collinear and none of them overlap each other, the complete distance from the point A to the point P would be equals to x plus y. Okay. Now here we have a right angle triangle because the point D is the corner of this square. So now in this right angle triangle we will simply apply the Pythagoras theorem. Therefore height square, that is x square, plus the base square, that is x minus y, the complete square, would be equals to the hypotenuse square, that is x plus y, the complete square. And this all thing we are doing in the triangle APD. Okay. Now let us simplify this thing. Therefore x square plus, now x minus y, the complete square, will turn out to be x square plus y square minus 2xy equals to x plus y, the complete square, that is x square plus y square plus 2xy. Now we can see that x square plus y square can be cancelled out. So the final thing remaining over here would be x square equals to 4xy. Factoring out the x and dividing 4 on both of the side will finally give me the value of y equals to x upon 4. Now recall that we were using the variable y in order to determine the radius of the semicircle, and now we have got its value in terms of x. So the first goal is accomplished, that is to get the radius of the semicircle in terms of x, and that we have got as x upon 4. Okay. Now I will just remove all this working related to the semicircle because we are now jumping onto this circle. So now the goal over here is to get the radius of this circle in terms of x. Now as the circle is small, we have to zoom it a little bit. Now we can see that here is the center of this circle and it is tangent at 3 points. One over here with the quarter circle, one over here with the semicircle, and one over here that is the side length of this square. So the first thing that I will do is I will draw the radius to this tangent point, and it is a straight line. Hence according to the theorem, this angle would be 90 degree. This theorem is very common, that is, when we draw the radius to a tangent line, the angle formed at the point of the intersection would be 90 degree. Okay. Now this time we will mark the radius of this circle as a variable a. Now this angle C is also 90 degree because it is the corner of this square. Now from the center of this circle, we will simply drop a perpendicular to the bottom side of this square. So now we can see that here we have a quadrilateral, 3 of its angle are 90 degree. Therefore by angle sum property, this fourth angle is 90. Therefore this particular quadrilateral becomes a rectangle. Now in a rectangle, opposite sides are equal. So if this much distance is equals to a, the distance from the perpendicular to this point C would be equals to a. Now the distance from the point P to the point C is the radius of this semicircle, that was x upon 4. Some part of it is equals to a. Therefore the remaining part, that is the distance from the point P to this perpendicular, would be equals to x upon 4 minus a. Okay. Now the distance from P to this tangent point is equals to x upon 4, the radius of the semicircle. The distance from the center of the circle to this tangent point would be the radius of the circle, that is a. Now as these 3 points are collinear and they are not overlapping, the complete distance would be x upon 4 plus a. So now here we have a right angle triangle. The hypotenuse is x upon 4 plus a. The base is x upon 4 minus a. So when you will apply the Pythagoras theorem in this right angle triangle, the value of height, that is h, would be equals to 2 times the square root of x upon 4 into a. And if we will further simplify this thing, the value of h will turn out to be square root of x times a. Keep this equation as it is and let it be equation number 1. Okay. Now look carefully, we have utilized 2 facts related to the position of this circle. One of the fact was that it is tangent to the semicircle, and the other fact that it is tangent to the side of the square. Now the only remaining fact that we have not utilized is that this circle is tangent to the quarter circle. I will simply draw a line segment from the point A to the center of this circle. Complete distance over here would be equals to x plus a. Okay. Now previously we have dropped a perpendicular from the center of this circle to the bottom side of this square. Now this time we will drop a perpendicular from the center of this circle to the top side of this square. Okay. Now the angle B is also 90 degree because it is the corner of this square. This particular quadrilateral becomes a rectangle because all the 4 angles are 90 degree. Now as this is a rectangle, opposite sides are equal. The breadth of this rectangle is equals to a. Therefore the other breadth would also have a length a. The complete distance from A to B is equals to x. This much distance is equals to a. Therefore the remaining distance, that is from the point A to this perpendicular, would be x minus a. Now again we have a right angle triangle over here. The hypotenuse is x plus a. The base is x minus a. Therefore the value of the height that we denote as capital H, according to Pythagoras theorem, the value of capital H will turn out to be 2 times the square root of x times a. Keep this equation as the equation number 2. And the distance capital H is this particular line. Now this line is a straight line because this angle is 90 degree and that angle is also 90 degree. So 90, 90, 180. Hence if the angle at the intersection of two lines is 180, it is a straight line. Now this line is a straight line. This line is already a straight line because it is the side of the square. And this complete biggest quadrilateral form over here is a rectangle because all the 4 angles are 90 degree. And rectangle opposite sides are equal. Therefore the length from here to here would be equals to this much length. So let me write it over here, capital H plus small h, and this would be equals to the length present on the right hand side, that is ultimately the side of the square, and that is already equals to x. Okay. Now we have got the value of capital H, that is 2 times the square root of x times a. So 2 times square root of product of x a plus the value of small h we have got as square root of product of x a, and this thing equals to x. Now these two terms are like terms, so we can simply add this thing in order to get 3 times the square root of x a equals to x. We can square both of the side and simplify the like terms. So finally we will get the value of a equals to x upon 9. Now recall that a was the variable denoting the radius of the circle, and just now we have got its value in terms of x. So ultimately we have got the radius of the circle also in terms of x. So now I'm just removing this, and now we are going to move on to the final step, that is to get the area of this blue triangle. So now we are going to do the final part of the question, in which we will get the area of this blue triangle. Now recall that this point was the center of the square. Now there are many definitions to define it, but in our solution we will use this definition. In a square, the center is the point where the perpendicular bisector of the opposite sides meet. So if the perpendicular bisector of these opposite sides are meeting at the point is defined as the center of the square. So according to this fact, the perpendicular bisector of these opposite sides meet at the center of the square. Okay, these are the perpendicular points and they are bisecting the side. Now the complete side was having a length equals to x, and they are bisecting it, therefore the length will become x upon 2. And all the smaller quadrilaterals are perfect square, you can just check. Therefore the length of this perpendicular would be x upon 2, this perpendicular also x upon 2. Now let me just draw this thing very perfectly so you can understand it better. So perpendicular from here to here and other perpendicular from there to there. Okay, and both of these perpendicular are having a length x upon 2. Now you might see one more thing, that this perpendicular is meeting the other end of the semicircle. So is it a coincidence, or I have made a mistake in drawing this perpendicular? So it is not a coincidence, neither it's a mistake, it is a fact. Remember that the radius of this semicircle was x upon 4. Therefore the diameter of this semicircle, that is from here to here, would be 2 times x upon 4, that is x upon 2. Now as we can see, in this particular quadrilateral all the 4 angles are 90 degrees first of all. This means it is a rectangle. Now the length of this line segment is x upon 2, therefore the length of this line segment would also be x upon 2, and that we have got. Therefore this perpendicular will meet at the other end of the semicircle. Now we can see that this blue triangle present over here is not a perfect right angle triangle. This means it's not easy to get its area. So in order to get the area of this triangle, we have to break down the figures. So the first thing that I will do is I will redraw the things that we have done in order to get the radius of this circle. The perpendicular from here to here, that is ultimately the radius of this circle. Then we have dropped a perpendicular like this, and one more perpendicular from here to the top. Okay. Now this angle is 90 degree. By angle sum property, this angle is 90 degree, and we have already seen that this line was a straight line, therefore this angle 90, again that angle 90 by angle sum property. Now the perpendicular distance from here to here is ultimately the radius of this circle, and we have already got its value as x upon 9. Therefore this perpendicular distance would also have a value x upon 9, and let me just remove this thing from here, and the distance from this perpendicular to the point C would be x upon 9. Okay. Now the complete distance of this yellow line segment was x upon 2. This much distance we have got as x upon 9. Therefore the remaining distance, that is from the center to this particular point, would be equals to x upon 2 minus x upon 9, and this thing will be equals to, after taking the LCM, 9x minus 2x, that is 7x, divided by 9 into 2, 18. Okay, and this angle over here 90 degree by linear pair. Now look at the bottom. The distance from the point P to this perpendicular is the radius of the semicircle, hence it would have a value x upon 4. The distance from the point P to the point C is the radius of the semicircle, x upon 4. This much distance is equals to x upon 9. Therefore the remaining distance, that is from the point P to this red perpendicular line, would be equals to x upon 4 minus x upon 9. That would be 5 times x upon 36. Okay. Now recall that the distance from here to here we have marked as small h, and we have got its value as square root of x times a. Now we have got the value of a, that is x upon 9. Therefore square root of x times x upon 9 will give me an output that would be x upon 3. Therefore the distance h over here is ultimately having a value x upon 3. So I will write that thing over here. Okay. Now what about this other perpendicular? So look carefully, the complete distance from that perpendicular to over here is x upon 2. As this quadrilateral is a rectangle, opposite sides are equal. Now the complete distance is x upon 2. This much distance we have got as x upon 3. Therefore the remaining distance that we are ultimately trying to find would be x upon 2 minus x upon 3. That would be x upon 6. Okay. Now you might be thinking why we are getting the length of this line segments. So the reason is very simple and is ultimately related to the area of this blue triangle. Look carefully, this blue triangle was not a right angle triangle, so we cannot get its area directly. So in order to get the area of this blue triangle, we have to use the subtraction of area. We have to take the area of this complete rectangle, and from this we will simply subtract the area of this right angle triangle, this right angle triangle, and this right angle triangle. So what will remain is the blue triangle. So now let us do that thing outside the diagram. So the blue area that we are trying to find would be ultimately equals to the area of the complete rectangle minus area of the triangle 1 minus the area of the triangle 2 minus the area of the triangle 3. So let me just mark this triangle markings inside the diagram also. So this is the triangle number 1, this is the triangle number 2, and this is the triangle number 3. Okay. Now area of the complete rectangle, that would be length into breadth. Therefore x upon 2 into 7 times x upon 18. Area of the complete rectangle done. Minus area of the triangle number 1, that is this right angle triangle. Therefore half times the base, that is x upon 4, into the height, that is x upon 2. So this thing will turn out to be x square upon 2 into 4 into 2, that is 16. So x square upon 16 minus the area of the triangle 2, that is the upper right angle triangle. So area of this particular right angle triangle would be half the base, that is 7 times x upon 18, the height, that is x upon 6. So this thing will ultimately turn out to be 7 times x square divided by 36 multiplied with 6 minus the area of the triangle number 3. Now the third triangle is this one. The height of this triangle is x upon 3. The base of this triangle is 5x upon 36. Therefore the area of this triangle would be 5 times x square divided by 36 times 6. Okay. So now we can say that the denominator of these two fractions are equal, that is 36 upon 6. So they can be simplified. Therefore negative 7x square negative 5x square becomes negative 12x square divided by 36 into 6. So we can cancel out the 12 from the table of 6. So it will turn out to be negative 2x square upon 36. Now this negative x square upon 16 as it is. And in the beginning we have the positive 7x square upon 36. Now this thing and this thing can be simplified because the denominator is same. So this result would be simplify x square upon 36 minus x square upon 16. So in order to make this denominator same, we have to multiply 4 in this and 9 in that. So finally the blue area would be equals to, in the denominator we will have 144, and in the numerator 4 into 5, that is 20, 20 minus 9, that is 11. So the blue area in terms of x is going to be 11 times x square upon 144. Now this particular equation is a generalized solution, that is when the side of the square is x, the area of the triangle would be 11x square upon 144. Now in this original question the side of the square was given as 12. So according to this, the blue area would be equals to 11 times the 12 square, that is 144 divided by 144. So this thing will finally turn out to be 11 only. So finally according to this question, the blue area is equals to 11 units square, and this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.